Hi, everyone. Welcome to the DevOps Progression talks, and I'm David Justice. I'm a senior developer here at Microsoft working on Azure and open source, and we're going to talk today about Kubernetes and Chef on Habitat, or Chef Habitat, excuse me, on Azure. Just recently we had Chef Conference 2017, and I got to talk about Azure a bit there, and I was really excited to present building a Habitat package and deploying it out onto Azure Container Service with Kubernetes. So today, what we're going to go through is basically the next post out into this DevOps progression. You know, how to level up your DevOps. This is a little jump ahead from our last post. The last post was about level 1, and in level 1, we were simply putting together scripts. Repeatable scripts that allowed us to deploy infrastructure. In this one, we're really leveling up. We're not using infrastructure as code. We're going beyond that. We're going to use containers to build immutable infrastructure using Habitat packages. So let's get into it. Initially, we are going to run a script to provision Azure infrastructure. Let's take a look at what our environment has in it. So here we can see that we have an Azure, a Habitat, and a source folder. These folders, the Azure folder contains the provisioning script. The Habitat folder contains all the Habitat related stuff, and the source folder contains the Rails application that we're going to deploy. Again, if you haven't been watching or you haven't been reading these posts, we are going to build this Rails to-do app. It's Rails Ember and behind the scenes CosmosDB using a MongoDB wire format. So let me get a tree for Habitat. Okay, so we have Habitat config. We got a bunch of YAML configs under there. We have a default TOML file, hooks directory, plan, simple default. All right, cool. For the Azure provisioning script, we're just going to kick it off and see what happens. So this is going to build our infrastructure out. Let's walk through the script itself as it's provisioning. Okay, in these scripts, I've done my best to make them as repeatable as possible using Azure CLI and some basic constructs for deployment. So we walk through, set up some variables up front. We check if we're logged in. If we're logged in, we go with it. Then we go through and we build out our resource group. From there, we're going to set up a key. I know this isn't great. There's no password on the key, but this is just for demo purposes. You could add your own password for a key that you want to keep around or be more secure about it. Next, we're going to go through and build a Cosmos database. We're going to specify the kind as MongoDB. After that, we're going to create a Azure Container Service, and this container service is going to use Kubernetes as the orchestrator. Now, you can use Mesos. You can also use Docker Swarm. Today, we're going to use Kubernetes. I like Kubernetes. It's super fun to use, so let's use that. Registry. We are going to create a Azure Container Registry here within the same group and within the same location. We're going to give ourselves admin access, and then we're going to go in and we're going to log Docker into that container registry with the username and password that we get from ACR. And we can get that via ACR credential show. Then we're going to create our Kubernetes credentials and drop them in our home directory so we have access to talk to Kubernetes via kube control. And if we don't have kube control, we're just going to install it. Finally, we're going to create a default toml with a couple of our connection strings. This is how Habitat's going to get its package configuration info, or at least its default. So that's kind of our start. So let's see what happened with this script. So our script built out all the stuff that we wanted it to. It succeeded, and it's telling us that we can now push Docker images out to our container registry. It's telling us we have a cluster built up and proper user, and we have our kube control information or kube config out there. So let's see if we can talk to the cluster. Turns out we can. Super. So let's look at the portal. I've already brought up the portal. This is all of the stuff that it created. There's a bunch of stuff here. The key ones that we want to look at are the container service. We can see our container service. We have 2 VMs that we're running out there. There's not too many. We can add more agents if we wanted to, but let's not dig into that just yet. We also have a container registry that's out there. So, and then we also have our Mongo instance, our CosmosDB, which is really cool, and we can scale it across the entire world. It's awesome. If you run Mongo instances, or if you run Mongo clusters, seriously take a look at CosmosDB and running with Mongo wire format. I think you'll be pleasantly surprised. It's fantastic. So, all right, enough plugging CosmosDB. Let's dig into this. So, I know containers. You use containers with Kubernetes. You upload your images and you run your containers on Kubernetes. All right, so I have this app. I have Habitat. I don't know how I get to containers. So we, I guess, first have to see that we have an app that runs. So cd source, and we're going to bundle execute Rails server. All right. So clearly enough, we have an application that is out there, and we can see that it works, and we have stuff that shows. Okay, so we have a Rails app. That's helpful. All right, so let's hop into Habitat and let's take a look at what we're going to do there. So we go over to so let's hop into just building the package. So I guess, what is Habitat? Habitat is an abstraction over application infrastructure creation. So you can create an infrastructure package, not care where it's deployed, whether you're deploying it onto VMs, onto containers, wherever you really want it to go. And then it comes with this really awesome supervisor. And the supervisor runs, and it's going to watch your application. It's going to restart it if there's configuration changes. It's something that you normally have to think about setting up for any environment that you're working in. Now it just comes packaged with it. And what comes out of Habitat is basically a tarred gzip, but it's signed, so you know that it's not going to change in the future. So, all right, let's build one. So I'm going to enter into Hab Studio. And Hab Studio is this really cool kind of clean room that gives you the ability to build out your package and use whatever tools you need to create this immutable piece of infrastructure. So I'm in there. Let's just see what happens if I say build. It's doing things. Yeah, it's pulling down stuff from the interwebs, and it looks like it's building stuff. Okay, So I know I know what it's doing, but it looks cool when you see this. I mean, this looks like a tool that somebody loved. Somebody loved building this. It's pretty clean. It's also written in Rust, which it's lightning fast. If you look at the time here between like Habitat showing its help versus like Kubernetes, I mean, help is like such a trivial thing. Showing it should take like next to no time. Basically, you're just entering into your application and dropping out help. Maybe parsing some stuff in between. Just the application start time is just shocking. Like you're looking at an order of magnitude difference there, and it's not like kube control is all that slow. It's just the hab is just that fast. So it looks like Bundler got called and is installing all of our gems for this application. So let's hop into Hab and actually take a look. So in Habitat, you have your Hab, you have your config, you have your hooks, and you have your plan. Your plan is where you drop in. And it kind of looks like I'm describing a package of code as opposed to a piece of infrastructure, which is really kind of unique. That's interesting. Because really what I'm saying is I want this application to have these dependencies. Here are my package dependencies. And I want them to have this build dependencies. So this is how I'm going to build up this package. And then I'm going to expose something called the Rails port here, or port. Now this could be more descriptive, but for this really simple case, let's just go with this. These, like do download, do verify, do unpack, we don't actually need because we aren't pulling from some tarball. This we would use, or we would automatically use if we were pulling down a tarball. So our build happens in do build. We copy our source into our cache source path, and then we do a bundle install. We then run the install and drop it into a static path, and we replace some of the bin stub stuff so that it's using our core Ruby as opposed to the bin env. Because we don't have core utils available to us, we're kind of in a localized package system within Hab. We have to remove the magic lines. So what next? So what do we get here? We get we've described the package for our app. We've described where stuff goes. We've put it into a directory. So it's packaging up, and we can see here that we're now to the point where we produced this tarball, and now we're going to produce the heart. And we love it when a plan comes together. Okay, so we have this artifact. Habitat, when it goes to actually run the app, we have these things called hooks. And the init here runs when the topology first builds. So Habitat has the idea of topology. We're only going to be putting out a single service, but really it's meant for running an entire topology of services. So the init is kind of the bootstrap, put our files in place and get ready for the application to run. So in here, we just take where we first put the files, and then we put them into the service path. And the service path, for Ruby, we have a bunch of static RB files and config files and stuff like that. So we put them into a static directory. All of your variable stuff goes under service var, and we'll see a little bit more of how that works later. Actually, no, not in this talk. We also have our config path. So this is interesting. Where do these configs come from? So if we go to the config directory, we see that we have a handlebar templated configuration YAML file. This handlebar templated YAML file actually pulls in configuration settings from our default TOML here, or from configuration settings from the supervisor. Likewise, we templated the secrets for the secrets.yaml in production. Now, mind you, there's better ways to do secret management. I'm not going to get into that in this talk right now, but suffice it to say that this drops configuration values into those for you. And then in the init, we end up copying them into our path so that we have the keys to start the car, you know. We also have run, and the run hook gets run every time there's a configuration change, when the app first comes up, when it gets restarted. This is our chance to hook the environment and say, okay, I need to set up my exports. I want to make sure that I'm in a given directory, and then we fork, and we just run the process. I'm just going to run the Rails server here. You could run more advanced setups than this, just to get this running. All right. So also notice that we have a results folder now. That results folder contains our heart and our build environment. So here's our artifact. So we've mounted in that local source directory into the clean build environment, that container that's running Hab Studio. We're still within Hab Studio. Now I'm going to get an image. I want to get a container image. So I'm going to run hab pkg export docker divine, because that's the origin, and Rails to do. And voila, it is going through, it's pulling in the tools it needs to build this container, and it's actually building a Docker image for me. This is really cool. I am super excited about that because I've seen some really gnarly Docker files. I don't really like, I mean, you do what you have to do building Docker files, but they can get just really verbose. I feel like Habitat provides you kind of a more robust syntax for describing your application dependencies and packaging, and then outputting a container image. Maybe just preference, but you can see here, you get your expose, where the entry point is, and it'll just start up. It's awesome. Let's exit from there. Run -it. Let's go with -p 3000. I'm going to map 3000 into 3000, and we'll go to Rails to do. Okay, so starting up the process, you can see Habitat started up, hooks are recompiling, there's a gossip. So you have Habitat supervisors talking to each other over a secure network, gossiping between each other. Let's see if we have a app running. We sure do. And we can see that it actually went out and talked to Azure. It's gone out and started talking to MongoDB in Azure. That's fantastic. All right, so I'm going to close that up, turn that off, and boom, we gracefully stopped. We shut down nicely, and everything's ready to go for the next time. Thanks, Hab Supervisor. You rule. Okay, so next, we just got a Docker image running locally from a Habitat package. We're like 90% way there. Next, what do? We're going to go through and actually put it out to Kubernetes. So rather than watch me type all this, I'm just gonna go with it. Just rip out the script that I already have. Okay, so what are we doing here? Here we're going to take that image that we have, the latest. Actually, let's go and say Docker images. Okay, so we can see here we have our tagged image with the tag and time, and we also have latest. We have the Habitat clean room, the studio. Let's clear this out. That's not what I wanted. All right. Here we go. So Docker images. Now we have our registry, our private registry in Azure. We've tagged that image, and now we're going to push that image out. So this will take a minute. But next, we're going to tell Kubernetes to run this image that we're pushing out. Cheers. All right. Boom. Okay, let's run the Rails to do. So it's creating the container right now. Let's see. Yay. And it's running. Boom, it's up. Fantastic. Okay, so now what we're going to do is we're going to expose this Rails to do. On the load balancer, target port's going to be, we're going to have it exposed on 80 with a target port of 3000. Now, ACS, Azure Container Service, running Kubernetes here, is now asking for a public IP. And it's going to build out your public IP for you. Let me grab this and we'll just watch the services. So we can see that this one is pending right now. So we can see port 80 leads back to the internally mapped port of 31907 on this publicly, or on this cluster IP, for which we will get a external IP. This external IP you could then use to expose a DNS record for whatever you wanted to do with it. We'll see that in a bit. All right, cool. So we have a public IP externally exposed. Let's grab that. Actually, let's just hit that. Yay! All right, so we have our to-do list, and hello world. All right, so it appeared to work. Let's see what happened. I'm going to clear that out, and kubectl logs. Yeah, let's go. PO. All right, so let's look at the logs for this guy real quick. So we can see that the insert for to-do and world worked. The app started up. It's running on 3000, just the same way as it ran locally. That's a really cool thing to grok. We package this up. That infrastructure is immutable. It was bootstrapped and ready to go, and we could run it from our local Docker. We could test it that way. We could also test it inside Studio, and that can create a fairly tight dev loop. It's a really nice way to define your infrastructure. Okay, so we have that up and running. Fantastic. So what can we do now? Why don't we go and scale this up? Because we always need to have 90 million different processes running. And all right. Cool. Let's see what it's doing. Yay. Oh. Okay, so we ran into a little image poll issue, but it appears that everything kind of worked itself out. Thank goodness. Maybe there was a little network blip or something. So as you can see, I'll clear that out. As you can see, everything's up and running, and we have 5 instances of our load balanced server out here, or load balanced instances of this Rails app. So they're all running. Hopefully They're all getting some traffic. Let's see. Let's grab a different one. All right, sure enough, they're up and running. This one's gotten hit to do the find for to-do items. It's with an individual list item ID. There would be many list item IDs if we added more. So now we have our app running. We've scaled it up in Kubernetes. This is all running on Azure infrastructure and using Chef Habitat to do its packaging. So why is that better than our previous stuff? So I'll leave that up to you in reading Leveling Up Your DevOps. But basically, immutable infrastructure just cuts down on our need to think about complexity and reason about complexity across stateful infrastructure, things that change as time goes on, pets, things that we have to take care of over time. The next part is Chef Habitat introduces really cool things that we use every day in app development. We describe our dependencies. We use a dependency management system that says, like, when this package changes, I can go and grab the latest package, or I can lock to a version of package. And that's really useful for describing our application dependencies, our infrastructure dependencies. Another really awesome thing about that is our infrastructure dependencies understand the transitive closure of all their upward dependencies. So if something changes upstream, like maybe there's an OpenSSL vulnerability or something like that, we can take advantage of a build upstream and have a cascade all the way down. And let us know in the morning after we get our cup of coffee that, hey, it's time to deploy this app. There's a vulnerability that we saw. We've already rebuilt it. Here's the immutable piece of infrastructure that you can just go and toss out there. Shoot the others in the head, and your new app's out there. That's awesome. That's goodness. The next part is Habitat starts to introduce this idea of, like, intentions. My app exposes this service, this thing that you might want to consume, and it may need to be organized in a certain way. So you can start to reason in your system about intentions. You can start to reason about the state of your system autonomously. The system itself can figure out organization. This also lowers complexity. And really, that's the name of the game at the end of the day, is we want to lower our organizational complexity. And these systems are really complex already. What can we do to lower that complexity? And I think that's really our goal at the end of the day, is being able to grok and understand the state of our system and lower the amount of complexity that we have involved in that system. So I hope this was useful. Please feel free to reach out to me, David@Justice Microsoft, or via GitHub. Love to work with anybody out there. Yeah, thanks. Appreciate it.